Welcome back to the deep dive. Today we're taking one of those dense technical roadmaps, putting it under the microscope, and turning it into strategic intelligence you can use right away. Our mission today is all about Agentic AI. We are diving deep into the Agentic AI Roadmap 2026. This is front and center for any organization that's serious about scaling AI.
And this is not just theory. The sources you sent over are, they're a highly detailed step-by-step guide.
Right.
It maps out the entire life cycle, technical, organizational, all of it, for building these sophisticated multi-agent AI systems. We're talking from scratch all the way to a compliant running deployment.
And our job here is to give you the massive shortcut. We're going to distill these, 7 crucial phases.
7 phases, yeah.
And the goal is that you walk away with the essential technical know-how and maybe more importantly, the conceptual framework you need to actually manage this whole complex pipeline.
It's the difference between, just seeing a list of tools versus understanding how they actually fit together to build something that's genuinely intelligent.
Okay, let's get into it. Let's start at the very beginning with phase 1, building the foundation.
The bedrock.
The bedrock. If you're building intelligent agents that have to operate on their own, this part has to be flawless. What does the roadmap tell us about the toolkit you need?
It's very clear on the technical prerequisites, starting with languages. You need Python, of course.
That's the lingua franca of machine learning, no surprise there.
Right, but critically, it also calls for TypeScript and JavaScript.
Okay, hold on. Why the focus on the JavaScript and TypeScript ecosystem, especially when, the core AI is probably chugging away in Python?
That's a great question. It's because of the environment where these agents have to operate.
Okay.
An agent needs to talk to web services, to microservices, to front-end apps, to actually do anything. And TypeScript, with its strong typing, ensures that all those API calls between the Python core and the rest of the company's infrastructure are, robust. Fewer errors.
So Python is the brain, and TypeScript is the nervous system connecting it to the outside world.
That's a perfect way to put it. And it's not enough to just code the agent. You have to deploy and manage it, often alongside dozens of others.
Which brings us to the operational tools.
Precisely. Docker and Kubernetes. When you move to multi-agent systems, you absolutely need containerization and cloud orchestration. Docker packages up the individual agents.
And Kubernetes manages the whole symphony. I think we sometimes take Kubernetes for granted, but why is it so mission critical for agentic AI?
Because it's not a single application. It's a system of components that need to scale and, importantly, fail independently.
Right.
If your purchasing agent gets overloaded, you can't have it crash the inventory agent. Kubernetes provides that isolation, that resilience, running on something like Google Cloud that gives you the GPU power you need.
And the glue, tying all this together, the part that lets them actually learn is the deep learning frameworks.
Yes, TensorFlow and PyTorch. Proficiency there is just non-negotiable, and it's more complex than standard deep learning. Because with agents, you're not just training an LLM. You're often using reinforcement learning RL to teach them complex, multi-step behaviors. Things like navigating a supply chain. TensorFlow and PyTorch are the engines for those advanced RL models.
So that's the tech stack, the muscle. Now we have to shift gears because AI is more than code. It's the whole conceptual architecture.
Exactly. You can have all the right tools, but if you don't get the concepts, you'll build something incredibly fragile. We have to define our components, the AI agents, and how they work together in a multi-agent system.
And this is where the real challenge starts, right?
Right.
Moving from a single intelligence to a coordinated system. What's the key conceptual hurdle the roadmap points to?
The #1 strategic challenge is inter-agent communication and knowledge transfer.
Okay, what does that mean in practice?
Well, if your procurement agent learns a new, more effective negotiation tactic, how does it instantly and reliably share that knowledge with every other agent in the system?
That sounds hard. Complex systems tend towards chaos. So what are the practical components that help manage that interaction?
It really boils down to 2 things: memory and context. The source really hammers on state management and providing robust long-term memory.
State management, so that's like tracking where every agent is in its task.
Exactly. Did the purchasing agent get approval? Did the inventory agent confirm the stock level? Without tracking that state meticulously, the whole process just collapses into errors.
And long-term memory. This has to be more than just the context window of a normal LLM chat.
Oh, absolutely. This is what enables true agency. We're talking about giving the agent a cumulative, persistent knowledge base. So it doesn't just forget everything when a conversation ends. It's about managing these huge context libraries so the agent can actually evolve its behavior over time. That's real learning.
That understanding of memory and coordination is the perfect jumping off point for phase two, the integration and model stack. We have the foundation. How do we actually plug these agents into the organization?
This is where we expand the agent's ability to see and act on the world.
And step three is all about tools and integrations. The roadmap is clear. Agents can't live in a vacuum. They have to plug into external APIs, existing tools.
Right, connecting to core databases or integrating with GitHub for DevOps tasks, things like that.
But that raises huge control issues. You're giving autonomous software access to critical systems.
And this is why the development practice here isn't just coding. It's mastering advanced prompt engineering to guide the agent and really meticulous API integration. Every microservice that agent touches needs to be hardened and monitored.
That sounds both expensive and risky. How do you make sure the agent's decisions are actually reliable?
That leads us straight into step 4, the AI models and frameworks that provide the actual intelligence. And the roadmap points to a pretty diverse architecture. We're way past just relying on one type of model.
So what are the key power sources it identifies?
It's a combination. You need LLMs for reasoning and planning. You need reinforcement learning models for optimal decision-making, like we talked about. And you need generative models for content creation, like summarizing a report.
What I found fascinating is the focus on the frameworks that connect all these different models together. It's like the architectural glue.
It's the absolute linchpin. And the roadmap specifically calls out LangChain and LaMINdex.
Okay, so LangChain builds the chain of actions.
It's the scaffolding for the agent's reasoning process. And LaMINdex is the critical layer for what we call RAG retrieval augmented generation.
So LaMINdex isn't just a database tool. It's what gives the agent its external context.
Precisely. It lets the agents connect to external, real-time proprietary data and feed that into the LLM's reasoning engine. Without a framework like LaMINdex, your agents are stuck with just their pre-trained knowledge. They could make real-time decisions.
Okay, so once you have that synthesis, the code, the concepts, the integrations, you're out of the lab and into operations, which kicks off our final section, phase 3, deployment, monitoring, and governance.
This is the phase where you find out if your beautiful architecture actually survives contact with reality.
Step 5 is AI agent deployment and testing. The roadmap says deployment can be anywhere, right? Cloud, on-prem.
Yeah, from Google Cloud to on-prem servers, especially if you have data gravity issues.
Yeah.
But regardless of where it lives, two things are non-negotiable: security and scalability.
Security is obvious. These things have API keys. But why is scalability so key here?
Because successful agentic systems tend to grow virally in an organization. You need to be able to scale up one part of the system, say the sales agents, without having to scale up everything else monolithically.
And that brings us to testing. How do you even performance test something that's autonomous and not entirely deterministic?
It's more than unit tests, that's for sure. You need complex, multi-agent stress testing. You need adversarial testing to see how they interact in unexpected ways.
What happens when they all try to hit the same database at once?
Exactly. And this is where the roadmap first introduces operational monitoring tools like Prometheus, right from the deployment phase. You have to start instrumenting immediately.
Which flows right into step 6, monitoring and evaluation. Deployment isn't the finish line.
Not even close. Continuous monitoring is essential because agents adapt. You need to be constantly looking at performance metrics, analyzing logs, tracking their decision paths.
But how do you monitor something when its actions aren't always predictable?
That's where the evaluation part comes in. The source calls it training evaluation. You have to make sure the models are operating within defined standards. If an agent starts drifting or its decisions go outside of acceptable bounds, you need an alert to fire immediately.
And the roadmap names the specific tools for this, right?
It does. Prometheus and Grafana. Prometheus collects all the metrics from the agents, and Grafana gives you the dashboards to visualize it. That's how you track KPIs, find bottlenecks, and get the data you need to adjust the models based on real-world use.
Okay, we've built, deployed, and are now monitoring. Let's talk about the fuel for this whole machine, data. Step 7 is data management.
The sources for agents are incredibly diverse. From your internal systems of record all the way out to web data.
So the focus has to be on data integration.
Intense focus. We're talking advanced data pipelines designed specifically to feed these agents high-quality contextualized information. Because sloppy data integration leads to unreliable agents, period.
And the moment you say massive data integration, you run headfirst into the final and maybe the toughest hurdle, legal and ethical responsibility.
This is the final layer, and it's the one that can shut down an otherwise perfect deployment. All that data management is useless without a mandatory focus on privacy and compliance,
Why is compliance so much harder for an agentic system?
because the agents are autonomous. They pull and act on data dynamically across different systems, maybe even different countries. The roadmap specifically cites GDPR in Europe and HIPAA in the US.
Right.
So if an agent decides on its own to pull a data set with personal info from one microservice and combine it with another source, ensuring that whole data lineage is GDPR compliant, at the point of action is an exponential headache.
So compliance can't be a checklist you run at the end. It has to be baked into the agent's core logic and the monitoring tools.
It has to be.
Yeah.
This final step is what ensures is a safe and, legal deployment. If you skip the compliance checks, you risk everything you built in the first 6 steps.
Wow, what a journey. We went from the foundational stack Python, Docker, Kubernetes into the conceptual challenges of multi-agent communication and memory. We architected it with frameworks like Llama Index, made sure it runs with Prometheus, and then locked it down with compliance for GDPR and IPI.
The roadmap's purpose isn't just to be a list of tools. It's to show that success requires integrating deep technical skill, robust operational monitoring, and rigorous continuous governance. It all has to work together.
This is absolutely vital knowledge for anyone navigating this space. But as you look across this whole roadmap, it raises a really profound strategic question for you to think about in your own organization. Which is the greater long-term challenge? Is it maintaining seamless, accurate knowledge transfer between dozens of constantly evolving AI agents? Or is it ensuring absolute, real-time, global regulatory compliance, GDPR, HIPAA, and whatever comes next across all the dynamic data sources those agents rely on? That's the strategic trade-off to mull over as you start your own agentic AI journey.